Hello, everybody. This week we're going to take a look at doing basic hypothesis testing now using Excel. So we've looked at in the main lecture how to do these calculations for hypothesis testing by hand. Now let's look how technology can assist us. Now, unfortunately, Excel does not have many built-in functions for your basic hypothesis testing. So we really are just using Excel as a large calculator with a normal and t-distribution probability functions in them. That's really about all Excel helps us with. So anyway, let's look at our first example here. GenX Seed Company claims their corn will grow to at least a mean height of 60 inches tall within 45 days of planting, with a standard deviation of 9 inches. A simple random sample of 250 GenX corn plants measured at 45 days gives a mean height of 58.75 inches. Test GenX's claim at alpha equals 0.02. So first thing we need to know here is the type of test. This is a test for population means. I should say for a single population mean. And as we look up here, this 9-inch standard deviation is for their claim. So that is a population standard deviation, which means this is a z-test. So then our hypotheses. We're testing their claim, so their claim becomes the null hypothesis. That is that the mean height will be at least greater than or equal to 60 inches. So the alternative is that that mean height will be less than 60 inches. Now we could find a z-critical here. Now we do that by looking at the normal distribution. This is less than, so this is a left tail test. So our alpha is all on the left tail, alpha of 0.02, so this is 0.02. So now we need to find what that cutoff value is, that boundary value right here for z. So this is going to be an normal inverse. So right there, norm inverse. The probability is 0.02. The mean is 0, standard deviation of 1. And we get a negative 2.054 is that cutoff. So negative 2.054 is that critical value. And so then, of course, we will lay out our rejection rule. We'll reject the null hypothesis. Oops. If the test statistic is less than negative 2.054, or if we're using a p-value test, we'll reject the null hypothesis if the p-value is less than alpha, in this case 0.02. So now let's go to Excel and do our calculations. So the first calculation we're going to do in Excel, come on, there we go, is our test statistic. So this is z equals, we're going to take our sample value, which is 58.75, minus our hypothesized value from the null hypothesis, which is 60. That's going to be divided by our population standard deviation of 9 inches divided by the square root of the sample size of 250. That gives us a test statistic of a negative 2.196. Now that already tells us that we're rejecting the null hypothesis because that is less than negative 2.054. Now let's find the p-value. So the p-value, this is less than, is our alternative hypothesis. So we need to find the probability of being less than negative 2.196. So this is norm.distr, negative 2.196, with a mean of 0, standard deviation of 1. And of course, true goes in for cumulative, giving us a 0.0141. So let's write that in. We had a test statistic of z equals negative 2.196 and a p-value of 0.0141. So both of them indicate, they should both indicate the same thing, that we are going to reject the null hypothesis, either because the test statistic of negative 2.196 is less than the critical value of a negative 2.054, or because the p-value of 0.0141 is less than alpha of 0.02. So that means that there is sufficient evidence in this case to refute Gen X's claim, and their seed actually does not grow to a mean height of 60 inches at the 45-day mark. So our next example. Round Off Crop Chemical Company advertises their Weeds No More weed preventer will keep mustard seed levels below 12 ounces per bushel of oats. A simple random sample of 68 bushels of oats gives a mean mustard level of 13.6 ounces per bushel with a standard deviation of 8 ounces per bushel. Test Round Off's claim at alpha equals 0.05. So now here it is the simple random sample of 68 bushel that gives the mean level of 13.6 and the standard deviation of 8 ounces. So that is a sample standard deviation. So our test type here, this is a test for a population mean, but since we have a sample standard deviation, this will be a t-test. So our hypotheses, well, Round Off's claim is going to be the null hypothesis, and that is that the mean level is less than or equal to 12 ounces per bushel. So the alternative will be that that mean level is greater than 12. Now we're looking for a t-critical value. So this is a greater than in the alternative hypothesis, so that means we're looking at alpha being all on the upper tail or the right tail. So that's 0.05. Now remember, when finding this boundary value, we're looking for the left tail. So that would be 1 minus 0.05 or 0.95. We also need the degrees of freedom. Since this is a sample size of 68, degrees of freedom are 68 minus 1 or 67 degrees of freedom. So we go to Excel. Put a new sheet here. We're going to equal 1 minus, because remember the t-distribution does less than, so for greater than, we're using, that's equals t-dist, we actually converted it to greater than already, equals, I gotta do inverse t, I'm getting the wrong function here, let me rewind. So t inverse, the probability is the 0.05 with 67 degrees of freedom. So we get a negative, there we got it finally, negative 1.668 is our critical value. So this is equal to a negative 1.668. So that means our rejection rule is we will reject HO, the null hypothesis, if the test statistic of t is greater than negative 1.668. Or if we're doing a p-value test, we will reject the null hypothesis HO if the p-value is less than alpha, in this case 0.05. So let's find the test statistic and the p-value. So again, to do the test statistic, we have to go ahead and put the formula in here. So this is going to equal our sample value of 13.6 minus the hypothesized value of 12, divided by the sample standard deviation of 8 divided by the square root of the sample size of 68, giving us 1.649 as our test statistic. The p-value then, since the alternative is greater than, it's going to be the probability that we have a t-value greater than 1.649. And so let's find that. This is where the 1 minus comes in. To get greater than 1 minus t distribution, 1.649 with 61 degrees of freedom, or 67 degrees of freedom. And this is going to be cumulative. So we get a 0.0519. So that means, let's go back here to our problem. So we have a test statistic t of 1.649 and a p-value of 0.0519. So as we interpret this, this is not greater, this should have been a positive, not a negative, sorry. This is not greater than 1.668, so we fail to reject HO on the critical value. And we should get the same result from the p-value, but let's double check. This is not less than 0.05, so once again, we fail to reject HO on the p-value. Again, both of those should be the same. So what this means is there is not enough evidence in this case to refute Roundoff's claim that their weeds no more keeps the mustard seed levels below 12 ounces per bushel. It doesn't mean we proved them correct or that we accepted that. We just failed to gather enough evidence to refute it. And in our third example here, Get Your Degree University believes their freshmen use campus housing at a rate equal to the national rate of 64%. A simple random sample of 500 freshmen at Get Your Degree University finds that 338 use campus housing. Test Get Your Degree's belief at alpha equals 0.06. So this is a test for population proportions. And so our hypotheses. So Get Your Degree believes that their freshmen use housing at the same rate as the national average. So they're saying that the proportion equals the national average of 64% or 0.64. So then the alternative would be that it's not equal to 0.64. So to get our Z critical here, this is a two-tailed test. So alpha gets split to both tails. How do we know it's a two-tailed test? Because it says not equal to in the alternative hypothesis. So that means it could be less than or greater than. So that means the 0.06 in alpha gets split equally to 0.03 in each tail. So this boundary value here has a left tail area of 0.03. This boundary value would have a left tail area of 1 minus 0.03 or 0.97. Again, they should give us the same value, just one positive and one negative. So let's do that. So let's go to a new page here. So this is going to be equal to norm inverse. 0.03 with a mean of 0, standard deviation of 1. And then equals norm inverse 0.97 with a mean of 0 and standard deviation of 1. And you can see those are the same value, just one's positive, one negative. So it's a 1.881 is the Z critical value. So that means our rejection rule is we will reject the null hypothesis if our test statistic is this tail is less than that negative 1.881, or if this tail here is if it's greater than the positive 1.881. Or again, just simply using the p-value, we'd reject the null hypothesis if the p-value is less than alpha of 0.06. So now we'll calculate our test statistic. Now remember, the test statistic here for a test for proportion, z is equal to p hat, which is the sample value, minus p naught, which is the value from the null hypothesis, over the square root of p times 1 minus p over n. Now we are going to use the p that is given for the population, which is the 0.64 or the 64%. So we go to Excel here. Let's find our test statistic. Let me spell that right. So z equals, it's going to equal, oops, we got to find our p hat. Let's do that first. So that's going to equal the 338 divided by 500. So that gives us 0.676. So now we can start our test statistic calculation. 0.676 is the sample value minus the 0.64, which is given for the population, divided by the square root of 0.64 times parentheses 1 minus 0.64, close parentheses, divided by the sample size of 500. We close the square root, and there we go. There is our test statistic of 1.677, giving us a p-value. Now remember, we start out by finding the probability, since this is positive test statistic and the alternative hypothesis is not equal to, we have to use the test statistic to tell whether we go less than or greater than. Since it's a positive test statistic, we're finding the probability that z is greater than 1.677, which will be 1 minus norm distribution, 1.677, with a mean of 0, standard deviation of 1, and of course, cumulative. But remember, this is a two-tailed test, so it could be further away from the mean if it were on the other side. Since it's not equal to is the alternative hypothesis, it could be on either tail. So we have to do that times 2. So the 0.04667 times 2 gives us 0.0935 is our p-value. So now back to our original problem. Our test statistic, z, is 1.677. Oops. And our p-value is 0.0935. So here we have the test statistic of 1.677 is not greater than 1.881, definitely not less than negative 1.881. So we would fail to reject based on that. And of course, verifying with the p-value of 0.0935 is not less than 0.06. So that reaffirms that we fail to reject HO. So what that means is there's not enough evidence to refute Get Your Degrees University's belief that their freshmen use campus housing at the same rate as the national average. So as you can see here, Excel is not terribly useful and one sample hypothesis testing. It's basically a glorified calculator. Really, all we're using it for is the normal distribution and inverse normal functions and the t distribution and the inverse t functions. Outside of that, it really is just calculating for us. Next week, when we do two variable tests, it will have a little bit more built-in function to help us out. So with that, we'll see you all in class. If you need anything, please let me know.